Welcome to Chemtech laboratory tutorial. So today we are going to be doing some questions and answer. Today we are going to be doing some question and answer. And sincerely, I want to apologize for coming this time online, but I think it's better for me also and for everyone, so that our full concentration will be on this video. So if you are there, just simply say hi. So today is question and answer. Questions and answer. Question and answer session. So we are going to do question and answer session. So I'm still trying to fit so that it will be clear for everyone to see. So if you are online, say hi. Just type hi. While we are waiting for others to join, we okay, I can see Adebi Enoch. Okay. We need more people to join. We need more people to join. So we need more people to join. Good. So today is a question and answer. I'm going to be sending some questions. Then you are going to be the one to send me the answer. Thereafter, I will send the correction. So are we okay with that? I'm going to be sending question on gas law. I'm going to send question on solution. I'm still going to send question on thermochemistry, thermodynamics, chemical equilibrium, down to acid and base. So what kind of question can we look at in gas law, starting from gas law? If you are there, just say I'm there. Keep on sending eyes so that I know that you are present. So for gas law, question like this should be, for example, 3 grams of helium. Let's say 3 grams of helium, 4 grams of nitrogen gas. 3 grams of helium, 4 grams of nitrogen gas, then 6 grams of argon. 6 grams of argon were introduced into a 15 dm³ vessel. Were introduced into a 15 dm³ vessel at 100 degrees Celsius. 15 dm³ vessel at 100 degrees Celsius. At 100 degrees Celsius. What are the mole fraction of helium, nitrogen, and argon in the system? That is the question. What are the mole fraction of helium, nitrogen, and argon in the system? Then 2, calculate the total pressure of the system and hence the partial pressure of each gases in the vessel. So you see, they said calculate the total pressure of the system and also the partial pressure of each gases in the vessel. How do we do? We have the molar mass of helium to be 4. Molar mass of helium is 4. Molar mass of nitrogen is 14. And molar mass of argon is 39.9. Is 39.9. And 1 atm equals to 1.0132 times 10 raised to the power 5 Newton per meter square. So that is the question. So are we okay with the question? They said we have 3 grams of helium. I'll take that again. 4 grams of nitrogen gas, 6 grams of argon were introduced into 50 DNQ vessel at 100 degrees Celsius. The questions are, what are the mole fractions of helium, nitrogen, and argon in the system? The mole fraction of helium, nitrogen, and argon in the system. And the second question is, calculate the total pressure of the system and hence the partial pressure of each of the gases. So, can we solve that on our own? It is easy. When we talk about mole fraction, I said you have to look at all the elements that are present. The first thing to do is to calculate the total mole of all the elements present. That is the total number of moles of helium, nitrogen, and argon. You will add them together. And since the question was not given in mole, it was given in mass. So you know that to calculate mole is that you say number of moles is equals to mass over molar mass. So for each of the elements present in the question, you should calculate the number of moles. Then after that, you add up all the moles of both helium, nitrogen, and argon, add them up. Then when you have done that, you will begin to look for the fraction, the mole fraction for each of them. So let's go. So for helium, it is what? 3/4. Why is it 3/4? Because 4 is the molar mass of helium and 3 is the mass given to us for helium. Then same, nitrogen gas is 4/14. That is gram, and this is gram per mole. Gram per mole. You see that gram will cancel gram and we are left with mole. So it means you have calculated it in mole. Then argon is what? 6 gram all over 39.9 gram per mole. So somebody should do the calculation for helium number of moles, nitrogen number of moles, and argon number of moles. So I'm going through the comment section to get your answer now. What do you have for helium number of moles? 3/4 will give you what? 0.75. So for helium, 0.75. 5 mole. Then for argon, for nitrogen, 4/14. 4/14, good. That is for nitrogen is what? 0.28 moles. 0.29 mole. That is for nitrogen. And for argon, 6/39.9 is what? 0.15. For argon, it is 0.15 mole. So the next step is to calculate the mole fraction for each. How do you calculate the mole fraction for each? You will add up all the moles, then use each to divide the total. That is how you to calculate mole fraction for each. Like I always tell you, you will do it as Na all over Na plus Nb. Meaning if we have 2, you make it 2. If it's 3, you continue Nc to infinity. So for helium, it will be 0.75 all over the sum of both helium, both nitrogen gas and argon. So add up together, what do you have for helium? For helium, somebody is not saying something right. No, molar mass for nitrogen said is to be 28. Yes, correct. That means someone is following me too. So it is divided by 28, not 14, because we have 2 molecules of nitrogen. So 14 times 2 will give us 48. So divide that again. 4 divided by 28. 4 divided by 28. 0.14. So your total for your mole fraction for your number of moles for nitrogen gas is 0.14. So you are going to add them together now. 0.14. Add them together. 0.14. Thank you for that. Yes. So let's add them together now. 0.75 plus 0.14 plus 0.15. What do we have? I think 1.04. Good. Then 0.75 divided by 1.04. What will be helium mole fraction? Helium mole fraction will be what? 0.58. Are you sure about that? 0.4. 0.72. So you have the mole fraction of helium to be 0.72. Then repeat the same thing for nitrogen gas and argon. So nitrogen gas is 0.14 divided by 1.04, and argon is 0.15 divided by 1.04. So what do you have? What will be the mole fraction for nitrogen gas and argon? 0.13. Good. 0.13. Then argon will be what? Argon is 0.13. Argon, is it 0.13? Okay. Some persons say argon is 0.13. Please. So we have gotten the first question, which says, what is the mole fraction? And we have calculated the mole fraction. Argon is 0.14, not 13. 14. 0.14 is argon, not 13. 14. Good. So we have succeeded in calculating the number of moles. The next thing they said, we should calculate the total pressure of the system and hence the partial pressure of each gas in the vessel. So what is the total pressure? Total pressure means that it is the sum of individual gases that are present in that container gives us the total pressure. So it means that you need to calculate for partial pressure for each of the gas before you can get total pressure. Are you seeing it? You need to calculate for partial pressure for each of the gas before you can get to total pressure. So how do you calculate partial pressure? Using your ideal gas equation, which says that PV is equals to nRT. So you calculate for partial pressure for each of them. Your N, you have already calculated your N to be 0. So can we continue? So can I clean the board now? So I want to clean the board so that we can calculate the partial pressure. Without the partial pressure, you cannot get the total pressure. So you need to know the pressure each of the gases excited in that vessel. Are you seeing it? So when you know that, you'll be able to get the total pressure of the vessel. So partial pressure of helium we identify with PHE is equals to what? nRT all over V. What is the V? The V is 15 dm². Our arrow value, what will be the arrow value that we will use? We will use an arrow value of what? 0.08206 atm liter per mole per Kelvin. That means we are going to change our Kelvin, our temperature that is given to us in 100 degrees Celsius to Kelvin by adding it to 273. So for helium, what is the number of moles you calculated for helium? It is 0.75. You are not going to use the partial, you are not going to use the mole fraction, but you are going to use the mole that you actually look for by dividing 3 over the molar mass. That is what you are going to use. Why do we not use the mole fraction? We do not use the mole fraction because we cannot, mole fraction is related to the partial pressure. You have to know the partial pressure before you can know before you can do the total pressure. So you cannot, the mole fraction is related to the partial pressure. Where we say mole fraction times the total pressure will give us the partial pressure. But in this question, the total pressure was not given to us, so you cannot use the mole fraction. So you use the number of moles as 0.75. 0.75. So times 0.08206. This 0.08206. Then your temperature, which is 100 plus 273, will give us 373 Kelvin divided by 15. 15 is in DNQ. 15 is in DNQ. So some of us have already calculated the partial pressure of helium. So tap your calculator, do 0.75 times 0.08206 divided by 15. What do we have? Some say it's 1.5 atm. No, I said we cannot use the mole fraction. For you to use the mole fraction, you have to know the total pressure. That is why you cannot use the mole fraction. So you use the normal mole that you know to give us the partial pressure. So are we all sure that it's 1.53? So 1.53. So the partial pressure for helium is 1.53 atm. 1.53 atm. Make sure you always put your unit, because without the unit, you are not actually telling the person that you are looking for partial, you are looking for pressure. So you have to put your units. Since it's a JAMA question, if it is a JAMA question where you don't need to show workings, the units are very important. Okay, so now we move ahead to calculate for the partial pressure of nitrogen gas. So using the example that I've done with helium, you now calculate that of nitrogen gas and argon, and send your answer in the comment section. Please ensure you indicate it that nitrogen gas partial pressure is this atm. Make sure you put your atm. Make sure you put your atm. So can someone now tell us the partial pressure of nitrogen gas using the same formula? So nitrogen gas is indicated as what? The mole we had was 0.14 times 0.08206 times 373 all over 15. Argon. Okay, someone has calculated that of argon to be 0.31, and that of nitrogen is what? Nitrogen is what? What is nitrogen? 0.29. Are we sure it's 0.29? Yes, 0.29. 0.29. That is the partial pressure of nitrogen. 0.29 atm. And that of argon, someone calculated argon to be 0.31 atm. So you are now to get the total pressure of the system, you will add the three partial pressure together. You will add up the three partial pressure together to get the total pressure of the system. So the total pressure of the system is 2.13. 2.13. That would be the total pressure. Total pressure of the system is equals to PHE plus PN2 plus P argon. So when you sum them together, you have 2.13 ATM. So when a JAMA question is given to you, they don't show working. Your own is just to put the answer with the unit. Your own is to put your answer with the unit. So the total pressure is the sum of the partial pressure of helium, partial pressure of nitrogen, partial pressure of argon, and all together is 2.13. I think that is the question for gas law. Now the next question, I'll just take review of few comments before we go to the next question. I'll take review of few comments before we go to the question. Say nitrogen is 0.31. No, it's argon that is 0.31, not nitrogen. Somebody is still asking, are we doing JAMA question? Yes, we are. Yes, we are. So I hope this I hope this reminds you of how to calculate partial pressure. So the next similar question will be from your colligative properties. But before this, we will first of all do that of phase diagram. Phase diagram, transition of the three states of matter is a phase diagram. So we are going to ask ourselves questions on that phase diagram. Question and answer. So let's take down this question. When you have a graph like this, and from here it moves to this point, then we have vapor, liquid, and solid. Then from here we have TC. Here down we have TP. So the question is, what is TP and TC? I'm asking you the question, what is TP and TC? What is TP and TC? TP means what? We should know that to be triple point where the three states of matter meet. And TC means the critical what? Temperature. The temperature at which gas becomes supercritical what? Fluid. The temperature at which gas becomes supercritical fluid. So the next question under this is, under what condition will this phase diagram sublime? Under what condition will it sublime? So that is the next question. Under what condition will it sublime? So when they ask you under what condition, they are trying to tell you to tell us, is it at high temperature or low pressure, or high pressure or low temperature? At what condition do sublimation occur? That is the question that is put forward. So at what condition does sublimation occur? Sublimation occur at what? High pressure, low temperature. That is why when you put camphor in your wardrobe, what happen? At low in your wardrobe, you don't have a light per se, or it's just at room temperature, because I don't think you put on fire in your room. And by the time you see at cold region, your camphor has disappeared. Are you seeing it? Compared to when it's in hot region. So at high pressure, low temperature, um this component will what? Sublime. What does The next question is, what phase does Z exist at 298 and 10 raised to power 5 Pascal? Okay, sublimation occurs at low pressure. 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 That is when sublimation occur. The temperature is below the triple point temperature, and the substance are. So when they say at what condition does this component, that when they say component, it means this phase diagram represent what? Z. So at what temperature, at what condition will this phase diagram sublime? If you look at it, moving from solid to liquid, you see the pressure lower there. Are you seeing? So at a low pressure, looking at the vapor, at low pressure, the Z will what? Sublime. At triple point temperature, at triple point low pressure, sublimation will what? Occur. So I think that is taken. So that is the question from phase diagram. Next is colligative properties. Colligative properties. We are going to be looking at questions. You are to give me your answer and to look through your answer and correct you based on the videos you have been watching. Let me remind us again. This is a question and answer session, so you can ask your question and answer. Okay, so I'm going through the comment section. uh Abijay said, "Ma, can't we use the total number of moles to get the total pressure?" Yes. You cannot, sorry, you cannot use the total number of moles to get the total pressure, because the total pressure is the pressure of the sum of individual gases that is present in the vessel. Are you seeing it? The sum of individual gases that are present in the vessel. So you need to calculate the partial pressure, because they also ask you for the partial pressure, then the sum. If you want to now calculate for the total pressure with the sum of all the mole fraction, sorry, all the mole ratio, and you're also okay, you can do that, but it's important you do the partial pressure first, since that partial pressure was asked. Then Faith is asking, can't we just get the total pressure directly from the total number of holes? Yes, you can. That is what I just said. You can. um this one say I'm lost in my network. No, please go to where there is network so that you will not be lost. Say, Ma, can't we use the mole fraction? you cannot use the mole fraction if you don't have the partial pressure. You can only use mole fraction when you have the partial pressure, or sorry, the total pressure, not the partial pressure, when you have the total pressure. But in this question, total pressure was not given to you, so you have to use their partial pressure. You have to calculate for that. Okay. Oh, oh, oh. So any more question? Okay. I'm seeing Skylord. Skylord, I will get your name later. And Ayiri. Ayiri say high pressure, low temperature. No, no. These components sublime at low pressure and not high temperature, but a temperature at triple point. Looking at this phase diagram, at what point? They are asking you at what point with this phase diagram sublime. So if you are looking at it, you know sublimation occur when solid changes to gas. When solid changes to gas. So look at the point where we have the temperature Tp. It now moves lower, going up. So it means it turns to gas when it's lower. So the pressure is low, the temperature is at triple point. Okay, under pressure and low temperature. Under pressure, under low pressure, pressures, it is under low pressure and temperature at Tp. Okay, now somebody is asking, Kenneth, what are the use of 23 dichlorovine dimethyphosphate? It's not related to what we are doing right now, so I wouldn't take that. That would be for another class. The ester, we said, okay, 2.98. I did not say 2.98. We calculated 2.13. Low pressure, temperature at triple point, not high temperature at triple point with low pressure. Yes. Precious is still asking, why does sublimation occur at low pressure? It occurs at low pressure because at that stage solid changes to gas. Solid changes to gas. You don't have to heat it. They say without passing through the liquid phase. Are you seeing it? So when you heat the solid, it means it has to pass through liquid phase before it will now. So, but sublimation is telling you that without passing through the liquid state, that is sublimation. So it means that you don't need to heat it. As it is with low pressure, it will change to gaseous. For example, camphor, potassium iodide. There are so many of them. Okay, so I think I should continue. I've wasted time looking at your comments. Please, if you don't understand, you can go through the video again. So let's go back to the osmotic pressure. The question is, what are colligative properties? What are colligative properties? When they ask such question, what are colligative properties? They are not telling you to say the factors affecting colligative properties. Are you seeing it now? They are not asking you to say the factors affecting colligative properties. Instead, they say what are colligative properties. So how do you answer such question? You simply say colligative properties are properties of a solution that do not depend on the nature, but only depends on the number of atom, moles, or ions that are present in the solution. So they do not depend on the nature. Nature means they do not depend on good. So ogome iwogomeyi iyalekoi, I've answered that. These are properties that do not depend on the nature of solute but depends on the number of solute. Now you have to complete it. You don't end it as number of solute, but you end it as number of solute of in ions, atoms or molecules. Number of solute in ions, atoms or molecules. So Osazuwa, Osarugwe, Mexi, you are okay. Good. So the next question is how differentiate between ideal and non-ideal solution. That is the next question. Differentiate between ideal and non-ideal solution. So what they want you to do is not just to, it's just to completely tell us that ideal solution is this, while non-ideal solution is this. So what is ideal solution? It obeys Raoult's law, while non-ideal do not obey Raoult's law. Are you seeing it now? So differentiate between ideal and non-ideal solution. Then lastly, the possible last question on colligative properties. How does the solution of a non-volatile solute affect the following properties? How does the solution of a non-volatile solute affect the following properties? And what are these following properties? Vapor pressure lowering, freezing point depression. How does it affect it? When a non-volatile solute is added to the solution, the vapor pressure begins to decrease. The vapor pressure will what? Decrease. Thereby, it becomes lowered. It becomes lowered. So, freezing point depression. How does it affect? How does it affect freezing point depression? How does freezing point affect? How does vapor pressure affect? How does the solution of a non-volatile solute affect freezing point? When a non-volatile solute is added to a solution, the vapor pressure, the freezing point decreases. Are you seeing it? With what? Delta TF equals to minus KFM. Delta TM equals to minus KFM. So that is how, yes, Osazuwa, you are very correct. Ideal solution obey Raoult's law. Its enthalpy change is equal to 0. Ensure that you put Y, because when you don't put Y, it means you are defining, and the question says differentiate. That is the question. The question says differentiate, but defining it alone will not give you any mark. It is just 0 because the question says differentiate between ideal and non-ideal solution. So the next question now is on, I'll quickly do the nuclear chemistry. The next question is on nuclear chemistry. Maybe tomorrow we can continue, because as I'm here, I'm already getting tired. Sorry. The next question is on nuclear chemistry. So let's go to nuclear chemistry and see the kind of question we should expect. Okay, you will leave live chat in the chat. Okay. I don't know what you mean by that. Oh, I don't know what you mean by that. So we are going to look at a nuclear chemistry question. and see the possible questions that can come out from there. Okay. Somebody just. Are we there? Please respond. Okay, the question is, if we start with if we start with 1 gram of strontium 90, strontium 90, 0.953 gram will remain after 2 years. If we start with 1 gram of strontium 90, 0.953 gram will remain. What is the half-life of strontium 90? How much strontium 90 will remain after 5 years? What is the initial activity of the sample in becquerels and curies? What is the initial activity of the sample in becquerel and curies? So that means you have to calculate and change the units to becquerel and curies. Are we there? Okay, the question is, let's write down the question, please. Let's write down the question. I will not be able to copy it on the board because I will use the board to calculate. Eh? I will use the board to calculate the question. If we start with 1 gram of strontium 90, if we start with 1 gram of strontium 90, 0.953 gram will remain after 2 years. 0.953 gram will remain after 2 years. What is the half-life of strontium 90? What is the half-life of strontium 90? How much strontium 90 will remain after 5 years? And what is the initial activity? What is the initial activity measured in becquerel and curies? Measured in becquerels and curies. So have we taken down the question? So if we are taking down the question, they said what is the half-life? The question is, what is the half-life that will be there after? I think I need to copy the question. What is the half-life of strontium 90? If we start with N1, that means N0, the initial number of atoms of strontium. Strontium 90 is written as SR90. Are you seeing it? Telling you that the mass number is 90. So if we have this, they said the initial, if we started with 1.0 gram, is that not it? Then the NT, which is the at time t, is 0.953 after 2 years. So that means After 2, time is what? 2 years. Time is 2 years. So what do you do? Remember that we say nt is equals to nt is equals to, hope we can see. Okay, thank you for that. I'm shifting the camera. Okay, thank you. Nt will be equals to n naught e exponential lambda t. E exponential lambda t. E exponential lambda t. They said if we start with 1 gram of protein, 0.3 will remain after 2 years. So what is the half-life of protein 90? So the time is 2 years. So if after 2 years, what will be the half-life? So what it simply means is that the 2 years, what is the decay constant at 2 years? So that is the first thing you do. You need to look for the decay constant, which is lambda. Then from there, you will now look for the half-life. The half-life. So how do you go about it? Decay constant is given as 0.693 divided by 2. That's what you do to calculate decay constant. Decay constant is calculated as 0.693 divided by 2. So divide that by 2. 0.3465. That will be the answer if you divide that by 2. So your decay constant is equal to 0.347. That is your decay constant. So if you have gotten your decay constant to be that, the next thing is to calculate for the half-life. The next is to calculate the half-life. So how do you calculate for the half-life? You will now use the formula to calculate for half-life. They said the original was 1.00. Then after 2 years, we have a 0.953. Next, the decay constant for after 2 years was 0.347. So your own is to now put these parameters into the question, into the formula that says nt is equals to n naught e lambda t, which is 0.953 is equals to 1 times exponential minus 0.347 t half. You know it's the half-life you are looking for, t half. This is what we are looking for. So how do you do that? When you first, to make this one standard of the formula, you make it subject of the formula t half. How do you make it t half? So how do you make t half subject of the formula? You should know how to do that. Be t half 0.347 t half equals to 0.953. So you will introduce logarithm, because when you are removing exponential, remember you will introduce what? Logarithm. So it will be minus 0.347 t half equals to log 0.953. 3. So that is how you do it. Then you now divide through by 0.347. So what do you have? Okay, the board, sorry. I think we can see it better now. So make T have the subject of the formula by dividing through by 0.34. So what do we have? I'm waiting for you to tap your calculator. So you are going to solve that. So let's for the sake of those that don't understand, I'm going to redo it well for us to see. But I'm seeing that some people are giving us answer that I don't understand. So look at it again. Let's go through the question again. So the question says we should calculate for half-life. And we know that to calculate for half-life, when the number of atom at time t is given to us and the initial number is also given to us, the formula is what? What will be the formula? The formula is nt equals to n naught. See, I've written it here. Nt equals to what? N naught exponential minus lambda t. Are you seeing now? Put the parameters into the question. Nt was given to us as 0.953. Is that not it? And N naught was given to us as 1. Then the exponential, we have to calculate for decay constant. That is divided by 0.347, then T half. So remember that I said that if you have NT, all of you divide through by N naught. Is that not it? You have N naught, it will be E minus lambda T. So to remove exponential, you introduce what? Your natural logarithm. Are you seeing it now? To remove exponential, you introduce natural what? Logarithm, which will give us T N naught equals to minus lambda T half. Are you seeing it now? T what? Half. So what is the value of NT? Is 0.1. That is why I just divided through by 1. Eh? So that is the first step. Now we have gotten, sorry, you put your natural logarithm. So it means N 0.953 divided by 0.347 is equals to T half. So what is your value? What is your value of T half? Remember it's minus and it's natural logarithm. What is your value? Then I to cancel E, to remove E. Yes, N naught is 1. Yes, N naught is 1. We have divided it by 1. Anything divided by 1 is the thing now. So you shouldn't be asking that question. How did we get the value of lambda? We got the value of lambda. Look at the board. We got the value of lambda by dividing 0.693 divided by 2 because they said it's 2 years. 2 years. So we are working with years. 2 years. We are working with years. Natural logarithm. Zero point. Divided by 0.347. So you will have it as 0.14. 0.14 is your half-life. 0.14 years. Ensure that you must put the unit to 0.14 years. So you can convert the years to seconds. You can convert the year to seconds. But I don't think there's any need for conversion because the question was in years and they didn't tell you to convert to, in the question they didn't ask us to convert to seconds. So how much protein will remain after 5 years? How much protein will remain after 5 years? That means you are looking for what? NT. NT. That is what you are now looking for. Then your half-life this time, will be what? 5 years. That will be your half-life. 5 years. Your lambda remains 0.347. Your lambda remains 0.347. So you can put the equation together to calculate for that. What is the initial activity of the sample in Becquerel or Curies? In Becquerel and Curies. So activity, we know that activity is calculated as what? Initial activity is calculated as what? Means you will calculate the activity at time t. So you should know how to do that. So you give me the answer of that. So that is the question for nuclear chemistry. Those are the questions for nuclear chemistry. Question for nuclear chemistry. So curie is a large amount of radioactivity. 1 curie is equals to 3.7 times 10 raised to power 10 radiation disintegration per seconds. That is 1 curie is equals to 3.7 times 10 raised to power 10. Then it means that when you have gotten your activity, you multiply it by what? 1 curie, because they said look for your answer in curie. And 1 curie is equals to 3. Then 1 becquerel, 1 becquerel, that is sorry, not becquerel, becquerel, becquerel. Please, you know I'm not an English, I'm not a French woman. I'm a Nigerian. So 1 becquerel is equals to 1 becquerel is equal to, say amount with curie, 3.7 times 10 raised to power 10 radiation disintegration per second. So once you just get your answer, multiply your answer by 1 curie. Multiply by 1 curie. Yes, I've given you the question before. I told people to write the note, so you can go through the video to get the question and know what we are talking about. Then lastly, the last one I will take for today is the acid base. To calculate it in curie, just multiply your answer after getting your initial activity. Multiply your answer by 3.7 times 10 raised to power 10. At least you should know how to calculate activity now. You should know how to calculate activity. I have done that in previous video on how to calculate activity. So you can go through the video and see. I'm already getting tired. When they say activity, I'm only taking this activity because that is one of the easiest questions in nuclear chemistry. So I will just breeze through. Activity means that at what will be the fraction remaining that will be active after you have after the radioactive compound that be disintegrated. What will be the remaining fraction? So activity is equals to nt all over n naught. That is the meaning of activity. Nt all over n naught. That is fraction remaining. But now in this question they said initial activity. Initial activity means the initial one all over the final one, all over the final number of integration. So n0 all over nt will give us the initial activity. So you will now convert that activity. 1 curies means 3.7 times 10 raised to power 10. So whatever you have as your initial activity, you multiply it by 3.7 times 10 raised to power 10, and the answer will be reported in curie. Curie, those people that discover radiation, radioactivity. Curie. So the last question that we'll take for today is the acid and base. Acid and base. The acid and the base. So let's take down the question. Let's take down the question for acid and base. Are we ready? Are we ready to take down the question now? Please, I want to see more response. Are we ready to take down the question for acid and base? Okay, so let's take it down. A 0.04 molar solution of 9C. A 0.04 molar solution of niacin. Niacin is spelled Niacin. Niacin. And the chemical formula of niacin is 6,5H4NOOH. C5H4NOOH. One of the beta vitamins has a pH of 3.26. Has a pH of 3.26. What is the acid dissociation constant for niacin? What is the acid dissociation constant for niacin? That is what they are asking. What is the acid dissociation constant for niacin? And remember that the chemical formula for niacin is C5H4NCOOH. C5H4NCOOH. So let's look at it together. It says 0.4 molar solution of lysine. 0.04 molar solution of lysine. And I said the formula for lysine is 6,5H4NCOOH. Has a pH of 3.26. Has a pH of 3.26. They now said we should calculate for the acid dissociation constant. The symbol for acid dissociation constant is Ka, which means that you will need to put this into equation to get the product over reactant when it dissociates. So that is the first step you do. So you put in C5H4NCOOH. We dissociate. We dissociate to get H4 NCOO minus plus hydrogen ion. Are you seeing it? So that means Ka is equals to concentration C5H4 NCOO minus, the concentration hydrogen ion all over the concentration of the reactant C5H4NOOH. This is what you do. So since they gave you pH and they gave you concentration of the niacin, it means that you can actually look for pH for hydrogen ion from where? pH. You look for the hydrogen ion, concentration of the hydrogen ion from pH, because pH is equals to minus logarithm of hydrogen ion, and pH was given to us as 3.26. So what will be the concentration of hydrogen ion? So the concentration of hydrogen ion will be antilog of minus 3.26. You know there's a minus here, so antilog of minus 3.26. That will be your concentration of hydrogen ion, and that will be the same concentration of your C5H4NCOO minus. So what do you have when you did antilog? What do you have? Antilog of 3 points. This thing. Antilog. What do you have? Are we there? Are we following? Antilog of 3.26. Good. That is 5.49. Are we correct? 5.50 is also correct. 5.94. No. Esther, recalculate and check. Antilog of 3.26. Antilog of 3.26. Good. That is 5.50. So the concentration of hydrogen ion is 5.50 molarity. 5.50 molarity. That is it. So that will be the same concentration of the lysine oxide. Lysine oxide. 50 molarity. So I will look at the question. If the question says at 25 degrees Celsius, otherwise it means you will need to calculate. Okay, so it's at 25 degrees Celsius, so it means that the hydrogen ion is equal to what? The lysine oxide. So alkoxide ion, which is 5.50 molarity. So that means your Ka will be equals to 5.50 times 5.50 all over 0.04 molarity. So molarity will cancel each other. So what will it be? What will be your Ka? What will be your Ka now? 5.50 times 5.50 divide by 0.04. Somebody tell us the AA. Times 10 raised to the power minus 4. Okay, 5.50 times 10 raised to the power minus 4 times 5.50 times 10 raised to the power minus 4 all of them divide it by 0.04. What do you have as your Ka? What will be the value of your Ka? 7.56 times 10 raised to the power minus 6. Are you sure? So I'm going to press my own calculator to be sure is what you have that I have. 5.50 times 5.50 times 10 times 10 is to the power minus 8 divided by 0.04. 1, 2, 3, 4, 5. Good. So we have 7.56 times 10 raised to the power minus 6. So that is the final answer. 7.56 times 10 raised to the power minus 6. So Ka is equals to 7.56 times 10 raised to the power minus 6. Remember that Ka does not have a unit because it's an equilibrium what? Constant. It's an equilibrium constant. Times 10 raised to the power minus 6 raised to power 10 raised to the power minus 6. Okay. So Olumo Joy, you are having 756.25 because you did not do your anti-log properly. If you do your anti-log properly, you'll be having 5.50 times 10 raised to the power minus 4. So do your anti-log properly to get the accurate answer. So the accurate answer is 7.56 times 10 raised to the power minus 6. 7.56 times 10 raised to the power minus 6. And lastly is equilibrium constant. That we can answer on our own. The only equilibrium, chemical equilibrium, I think we will need to know is to know when K is greater than Q. What is Q and what is K? K is equilibrium constant of concentration, that is reaction at equilibrium, mass action at equilibrium. While quotient is that the reaction is not at equilibrium. It's not at what? Equilibrium. So that is the difference between equilibrium constant of concentration K and quotient. You have to know the difference between them, and if K is greater than Q, where will the equilibrium shift to? If it's less than Q, where will the equilibrium shift to? And if it's greater than Q, if it's equals to Q, we know that it's what? At equilibrium. So thank you for the time spent for this revision, for this answer and question time, and I hope all of you passes your test, and I wish you success in all your endeavors. Every work that you have done, I pray for you to remember and to pass in your various subjects. And whatever it is, I wish you success, and I pray for you that God grants you retentive memory to always remember. In Jesus' name, amen. So thank you for watching, and please keep watching Chemtech laboratory tutorial. You can share, like, subscribe, share to your brothers and sisters, your friends. Please share, like, and subscribe. So that will encourage us to do more video That will also encourage us to do more life. Keep sharing, keep watching, and God bless you all. Success, success, and victory in all your endeavors. Amen. Please, if you have not subscribed, please subscribe. Please subscribe. If you just attended the live, please subscribe if you have not subscribed. Thank you. Bye and good night.